Welcome to Unit 5, Trig Identities, Lesson 0. We're going to review some grade 11 Trig Identities today, and we're going to do 4 types. Learning goal is written there, I'll have you read it. Here we go. A trig identity is an equation that is true for all values of the variable for which the expression on both sides of the equation are defined. To prove that an equation is not an identity is easy. Simply sub in the value of x. If the left side doesn't equal right side, the equation is not an identity. Now you might get lucky where it is, so you might want to try a couple to do that. To prove that an equation is an identity, you must prove that any value of x is a solution, not just one. To prove that an equation is an identity, start with the more complex side of the identity and transform the expression into the exact form the expression on the other side is. This is what I would always do. I start with the tough side and let the other side be your guide. The best way to improve your skills is to practice them. Pretty straightforward. Note each of the questions below use only the grade 11 U identities. None of the grade 12 identities will be used here. We will have a lesson, I believe lesson 4, where we will use the grade 12 identities as well. Alright, so continuing on. I'm going to do one section. There's 4 sections, one section for each video. So the first section is this, expand and simplify. So these ones always have brackets. So part A is always done for you, so I'm not going to really talk much about part A, but I'll do the other parts for you in the video. So here we go, the first one. 1 plus tan squared times 1 minus cos squared is equal to tan squared, of course, x. So first thing I'm going to do is I'm going to expand here, so I'm going to FOIL this out a bit. So I'm going to tackle the left side, because it's a little more complicated. The right side is pretty straightforward, tan squared x. So here we go, left side. So my left side, what I'm going to do is I'm going to FOIL. So 1 times 1 times negative cos, tan times 1, and then tan times cos squared x. So here we go. So my left side will be this. 1 minus cos squared x. This is going to be plus tan squared x. And then finally I'm going to have here the always fun and enjoyable tan squared x cos squared x. Excuse my terrible writing there. Alright, what do I do here, Mr. Wills? Well, now I would let's start converting things, especially tan, into sine and cos. So of course, the first one I'm not going to touch, so 1. Cos squared I can't change, so I'm going to leave that as cos squared x. Tan squared, though, I can change to this. I can change this to sine squared over cos squared. And then here I'm going to again change this guy, so it's going to be sine squared x over cos squared x, and times cos squared x. So there we go. I have all of this. What's really nice here is when I'm multiplying these two, I can see that this cos and this cos are going to disappear, so that's nice. And then over here, not really much is happening. So we'll have this. 1 minus cos squared minus, I'm going to bring that last term in the middle here because there's something fun that I can do with these two, minus sine squared x, and then here I'm going to have a plus sine squared x over cos squared x. Now you might be thinking, Mr. Well, that's fine, let's just do LCD here. No, because what I can actually do out of these two terms, I can factor out here a -1, because I can see an identity here, right? Sine squared plus cos squared is equal to 1, so I can see an identity here, so I'm going to use that. So what I'm going to have here is this, equals 1 minus 1, and I'm going to factor out that -1 into both of these, so here I got cos squared x plus sine squared x, and then plus sine squared x all over cos squared x. What do I have here? Well, this guy here is actually an identity. This guy here is actually equal to 1. So what I really have here is 1 minus 1, because this is just 1, so -1 times 1 is 1, and then plus sine squared x over cos squared x. Of course, I'm losing space here, but of course that's just 0. So what do I really have here? I have equals, well, sine squared x over cos squared x, right? These two are, of course, gone. And sine squared x over cos squared x is just equal to tan squared x. So what does this mean? So because upside down triangle, left side equals right side, therefore quaeresta demonstratum, I apologize for my Latin, it just means that which was shown has been demonstrated. So I've got it, right? Left side is equal to right side, and my left side is equal to my right side, so I'm done. All right, let's talk about that next one here. So sine x plus cos x squared equals 1 plus 2 sine x cos x. So again, not much I can do on this right side, but the left side here I can FOIL this out. So left side, here we go. So I'm going to really have here sine x plus cos x, and then here, whoops, sine x plus cos x. I can expand this out. So I'm going to have here, FOIL it out, so I'm going to get sine squared x plus sine x cos x plus cos x sine x. But of course, these two terms, this term here and this term here, really are the same. And let's do the last one here. So plus cos squared x. All right, so what do I have here? Well, I've got this sine x and plus cos x, or sine squared x plus cos x squared. So sine x squared plus cos x squared. Look at this again, this beautiful thing right here. This is just equal to 1. And then here I've got, these two are the same, so I really have 2 sine x cos x. And of course, so that's equal to 1 plus 2 sine x cos x. Oops. So, and I've got left side is equal to right side. So because left side is equal to right side, therefore quaeresta demonstratum. And that is part 1, expanding out some brackets and simplifying from there.